Are you looking for dynamic resources to energise your secondary science lessons? Well, here on Resource Review, we might be able to help. Today we're looking at 3. A CD-ROM, that's a virtual microscope.
And you grab it and you can move it around. Can you point out to me where the retina is?
A modelling software CD-ROM.
So we've got a huge difference between radio waves and light waves, which are 500 nanometres.
And this portable infrared thermometer. What will our panel think? Find out in a moment here on Resource Review. Joining me to recommend today's resources is Adrian Fenton, Curriculum Support Manager from the Association for Science Education. Joining Adrian on the panel, we have former West Midlands Teacher of the Year, Tony Gray, an AST and Head of Biology at King's Norton Girls' School in Birmingham. Joining Tony and Adrian, we have Mike Terry. Mike is Science Teacher at Alexandra Park School in North London. Welcome to you all. It's great to see you. Adrian, let's start with your first resource. It's called Bioscope, and this, I understand, is a fully functioning virtual microscope that comes on CD-ROM. Tell us more about it, and why is this any substitute for the real thing?
OK, the resource itself contains a number of slides that are virtual, as you rightfully said, but it's adding to the experiments that students might have experienced in their practical experiments through microscope work. In that sense, teachers could use it as with an interactive whiteboard to clarify the key points and what the students should be looking for. And it's an interesting development. They've perhaps got to the stage where you're actually adding to the experiments rather than replacing them, because a virtual environment shouldn't actually be replacing what the students should be doing.
Well, let's have a look. We visited the Grange School in Bristol, where AST Fiona Tate put Bioscope under the microscope.
You should be able to make a very quick, simple drawing of the whole eye when you come up and look at it. I've been using the Bioscope package, which is essentially a digital microscope package with a variety of slides included that you can look at on screen. Light's going to go through that when it goes into the eye, but it's actually got to get into the eye before it goes through the iris. Today we were looking at eyes, so I put the rat eye slide up on the electronic whiteboard running off a laptop. I brought the students up in groups to have a look at it, to manipulate it around using focus and magnification, and then to make a quick sketch of the eye slide. Play with the magnification, and then you grab it and you can move it around so you can actually have a look at those bits that are there. There was quite a good range of slides, an artery, a vein. They also had sort of larger organisms, whole organisms to look at as well. I think the package will be very, very good at A-level. It has an internal graticule that you can put on and off to scale and measure the size of different aspects of the slide under different magnifications. I think the product has some limitations just in it's not very big on screen. I felt they could have made far more use of having the slide box separately and used the screen to a much, much, much better advantage. Can you point out to me where the retina is, where the retina of the eye? At year 7, students really like using the microscope. It's quite new to them to get to use it and to make their own slides up. And I think that although, yes, they can manipulate it on screen with the computer, it loses something. And I think they would miss that.
Well, Adrian, we saw Bioscope in use. A slightly negative point that the teacher brought up was that she felt it was really well suited to A-level students. But at Key Stage 3 particularly, maybe 4 as well, pupils prefer hands-on microscope work.
I think that's a perfectly fair comment. You know, at Key Stage 3, I would definitely say that they should be doing real microscope work if you've got that equipment in schools, and this isn't replacing it in that sense. And as with any resource, you know, you've got to explore it a bit, and if it's not adding enough to what you can do practically, then perhaps it's not the thing that you need.
All right. Tony, what do you think of Bioscope?
I think that it is an A-level resource. I think if I was using it at A-level, it would be nice in that it gives you, the teacher, a lot of control, so that he or she can have 12 students all looking at the same selected material and they can discuss it on screen, although I'm disappointed to see how small it is on screen. But the other thing I would say is that for the price of this, you could buy yourself a really nice microscope cam, take photographs of your own slides, put together your own PowerPoint and do it tailored to your own needs at a fraction of the cost. Right.
So Mike, what do you think of this resource?
The most important thing is for the students to develop those practical skills, and I absolutely agree that this is not a substitute. I don't think it's necessarily even an add-on, but it is something that you could introduce into a lesson to, you know, it could be a starter activity at the beginning of a lesson to get the students thinking about something. It could be used at an end of the lesson to sum up and bring over a particular point. But the main, I think, area is A-level.
Tony, what did you think of the range of slides? There are 56 options, I think. Is that big enough?
Yes, I'm not sure that all of them are terribly relevant. I would go for quality rather than quantity. And I'm not sure how good the quality of the images really were. I only looked at a limited number of them. But, for example, on the blood, there was no facility for... You went in straight at 1,000 times magnification, which is difficult to achieve on a light microscope. So there was none of the business of we're going through low power, we're going through medium power, this is how we'd focus up. You wouldn't be able to focus on blood, on a blood slide, having used that one.
Well, interesting, Adrian, just finally from you, overall, not a very positive response from the panel.
No, I think it's all fair comments. It's an interesting resource where they've started to explore virtually adding to what should be done practically. Perhaps there are a few more stages needed before it's fully developed to meet its full potential.
OK, well, thank you all very much. Now let's move on to Adrian's second choice of resource. And this time it's designed for physics. It's called Crocodile Physics. Tell us, what is this resource, Adrian, and why do you like it?
Right, Crocodile Physics brings together a number of simulations that allow you to explore physics and its various areas for Key Stage 3, 4 and 5 students. This is an evolved product from the mid-90s that you could build little electric circuits, get the crocodile to eat up the bits that you don't want to use. But now they've added a lot of simulations and whiteboard material that teachers can use.
OK, thank you. We went back to the Grange School in Bristol, where teacher Dan Richards and his Year 11 class are making waves using Crocodile Physics.
Anyone else? Yes. Microwave.
I've used the Crocodile Physics software today as demonstrating how waves behave as a modelling piece of software. And for the most part, the kids responded well to it.
What this wave is doing here is, it is always going across that baseline.
Crocodile Physics comprises a number of different modules. There is a very interesting electronics section, which people will be familiar with from crocodile clips. There's also sections on optics, forces in motion and waves. We started off by showing them a conventional water wave, which is something that they'd be able to relate to, they would have seen it, and then taking that idea of movement, of energy, we showed them sound waves and how they were both different but also the same, and we showed how we could take a longitudinal wave and turn it into a transverse waveform.
So we've got a huge difference between radio waves, which have a wavelength that's as long as this room, and light waves, which have got wavelengths which are 500 nanometers.
The good points of the package are that it provides the kids with something to look at on the screen. They can see what I'm talking about while I'm talking about it. I can refer back to it. They can interact with the model as it is, and that provides a good scope of activity in the classroom. Overall, I'd say that the software is useful, and I think Crocodile Physics is a very interesting and a useful tool to deliver a topic like that.
Adrian, we saw Dan pull out some of the wave simulations from what Crocodile Physics has to offer. How easy is it for teachers to find what they need?
Well, it does take a bit of a while to get used to the modelling elements of Crocodile Physics. There's a lot in there. But there is also a service you can subscribe to called Crocodilia, which gives ideas on how you might use the different resources.
OK. Mike, what do you think of this resource?
Some of the applets, the simulations, which are like applets that you can get from websites, they just really enable the teacher to be able to set something up in front of a class and to show phenomena in physics which are often difficult to understand when you do a practical activity. And I think that that's a tremendous valuable resource.
Our physics department have had this for some time. I mean, I think they like the graphics, but I have to say they said they found it rather complex for the students. It's spent a lot of time setting it up.
Able students have no difficulty with it. The strength of it is for a student to actually see if you increase the voltage of the battery, you get a bigger current. There, the student themselves can do it in 4 or 5 minutes easily on the computer, and they can see that the current is the same all the way around a circuit.
Well, thank you all very much. Now let's move on to Adrian's third choice of resource, and for that I just need a couple of props here. Adrian, this, I'm told, is a non-contact thermometer. So tell us why you chose it, and with these two cups, show us how it works.
OK, right. This basically has an infrared beam. That means that you can point it at objects to tell what temperature they are. So if we're looking at the cups here, we get a little laser pointer that tells us where we're aiming at. So I'm looking at the left cup at the moment, and it's about 20 degrees. If we go to the right one, it's around 30, 33.
Oh, well, that's good. You got it right. I mean, basically, I had 1 cup of hot and 1 cup of cold, and I wanted to see whether you could do it. So they work, but, I mean, what use are these to a physics teacher?
If you're exploring which parts of the body are warmer, your hands compared to the main bulk of your body, or if we're looking at the temperatures looking down on top of it compared to the water surface area, what would happen if we put a lid on it? Would that affect the temperature of the lid? We can explore a lot of things to do with temperature and heat, because we wouldn't normally be able to put a thermometer in those places.
Well, what do you guys think of these?
There are obvious advantages. I mean, for example, if you're teaching physics, you've got to talk about energy transfers in light bulbs. And one of the things you try and encourage students to realise is that the low energy ones save a lot of money because you're not heating anything up in the way you do with a filament light bulb. And so if you were able just to point this at 2 light bulbs and at the same time have a meter which was showing you the amount of light intensity, you could show the kids straight away the advantage of the low energy light bulb compared with the ordinary one, and then you could go and explain the physics behind that. So I think there are lots of advantages like that.
But again, for teaching, I mean, are pupils going to respond well? Are you going to actually get them to be able to focus on what you're trying to teach and not just play around and point at everything in the class?
I think given the sort of expense, they're around about £40, you are not going to necessarily get a class set. And also the fact that they've got a laser in them means that there are certain health and safety things to be cautious with.
Well, I'm afraid that's all we've got time for today, but thank you all very much. Just to summarise, the 3 resources that we looked at were the Bioscope CD-ROM from Cambridge Hitachi, Crocodile Physics CD-ROM from Crocodile Clips Limited, and the RayTemp 3 non-contact infrared thermometer from Electronic Temperature Instruments Limited. For more information about all of the resources that we've discussed on today's programme, go to our website. It's teachers.tv/resource review. Or if you want to, email us resourcereview@teachers.tv. So I'd like to say a very big thank you to our panel, to Adrian, to Tony and to Mike. Thank you for joining us. We'll see you next time on Resource Review. Bye-bye.